only thing that's different here is, if you notice, our signs are different. Our signs are different, which can only mean that our compound inequality is different. Again, let's think about it. When we have an absolute value that's greater, so in this case, it is an OR. And again, what we just got done covering is when we have an absolute value that is less, it's AND. Again, that's the only difference. But we know that if we have OR compound inequalities, we cannot put them together and solve them at the same time. So the AND ones are a little bit easier. So let's solve this first one. We see that our inequality is eating the absolute value, or our absolute value is bigger. That tells us it's an OR compound inequality. That means we're going to solve it a lot like a linear absolute value equation, and we're going to write two different problems to solve. So let's copy our first one. Copy and paste. C minus 1 is greater than or equal to 5. Our OR in the middle. Now let's copy what's inside the absolute value. Again, anything in the absolute value bars does not change. So C minus 1. I'm not going to make this. C minus 1. Now we flip our sign and write the opposite of a positive 5. The opposite of a positive 5 is a negative 5. Okay, now we solve both equations separately. Over here, to get our C by itself, we have to add our 1. Because C is less than or equal to negative 5 plus 1. It's negative 4. Keep our OR in there. Do the same exact thing over here. We add our 1. We have C is greater than or equal to 6. Now we graph it. And again, this is an OR compound inequality, which means our OR graph is always apart. Remember the reference that I made in class last week? If it's peanut butter and jelly, they go together. If it's peanut butter or jelly, they go apart, right? So when we graph, we have 0. Let's put our 4, our 6, with our negative 4, and our negative 6. These two inequalities tell us that they're closed circles. We have a closed circle on negative 4. We have a closed circle on 6. And now we graph them each individually. Here, C is less than or equal to a negative 4. Again, two options. If our variable is less than, it's always left. Or, since our variable is on the left side, we can use our arrow, which is pointing left. Okay, again over here. C is greater than or equal to 6. Again, if our variable is greater, it's always right. Also, the variable's on the left side. Our arrow's pointing to the right, so we make it go right. Again, I do not care what method you use to graph, but it needs to be pointing in the right direction every time. So if you want to use the arrow method that we talked about, where the variable has to be on the left side, do it. If you want to use the greater than or less than that we just talked about, do it. It's completely up to you. Okay.